So let me give you the quick overview of the product, all the features, and then we can talk about how individual departments can benefit from it. We have more than 90 million chemicals in our database, and we have full chemical and toxicological information. And based on these properties, we provide the green scores, and I'll explain that in a minute what the green scores mean. So first of all, physical properties, we have more than 15 properties. We show the classification, NFPA classification, as well as the GHS classification. And we have more properties in our database than what you can see here, and you can pick and choose which properties you want to see typically. Other thing we have done is provide the information like the Lipinski rule of 5. For the pharma, this is important to understand whether the molecule is likely to be drug molecule or not. And then for the consumer industry, we will have certain classification that way as well. We also have related information. So, for example, benzaldehyde, which citations are actually referring to that chemical. So here you can actually see the number of articles that are actually referring to it, and this includes the articles, the technical articles, as well as patents. We have US and international patents included. You can see the abstract of the articles, and this is interesting. What this shows is the chemicals that this article is referring to. So you can actually then go back by clicking on the particular chemical and look at the properties of that chemical. So you can go back and forth and really help your research that way. And then clicking on this, you can actually go to the actual article. If you have access to the article from the publisher, it will show the full article. Otherwise, you'll have to request it. Going back to the chemical search, we just hovering over the specific names or the values, it tells you what they are, what units are used for those values, and get more information from there. We will at some point will also provide you the sources of these chemicals, where this data is coming from. You can actually see that information right now by going through our help and referencing at the high level what the sources are. Going to the toxicological data, we have more than 25 different properties, including the LC50, LD50 values. We do have LC50 values for number of species. We have chosen certain species that industry by default uses, but you can pick and choose your own species as well. We have data from bioaccumulation factor to ozone concentration, so really encompassing all the toxicological data, and where you see NN, that basically means that we don't have that data. This is a restriction, a limitation of the tool that we are using. We use industry standard tools were provided by EPA and REACH in Europe, and as we start getting experimental data, we will also be showing it side by side, where you see the estimated versus experimental data. You can compare up to 5 chemicals at a time, and that's one of the reasons we are actually showing you the experiment the estimated data, so the same method is used for all the 3 chemicals, and you can compare it easily. Just like in physical properties, just by hovering over it, you can see what the particular element means and what methodology was used to estimate that data. Here you see a little triangle. If it is yellow or red, that means there are some regulatory concerns. Just hovering over the triangle, it gives you the list of regulatory lists that actually refer this particular chemical. And now based on these properties, we show the scores. The scores and radial chart over here, you will see that there is a correspondence in color. And the radial chart actually shows you the scores in form of area. Bigger the area, more toxic the chemical is. So for the chemists who don't care about or understand the toxicological data specifically, can just look at the radial chart and understand what it is. Clicking on this radial chart, you will actually be able to see which components actually are causing the toxicity. So going back to that, we are going to have advanced search capability that so based on the classification of a chemical or for the property of a chemical, you can search on the chemicals. So as you can see, if you know what data point is actually causing the toxicity, you can search on those properties and find alternative chemicals that you could use, and then you'll be able to compare them in terms of the properties as well as the toxicity profile. Very easy to use and be able to make your own choices in terms of the alternatives instead of us telling you which alternatives you should use. The scores are at the top level: ecological score, health score, and safety score. And you can actually drill down on those scores, where, for example, air score is dependent on 4 factors: persistence, exposure, toxicity, and long-term effects. The persistence is within the media that we are referencing here. So we have water persistence, we have air persistence, soil persistence, and so forth. Just like in other tables, if you hover over the name, it shows you what it means, and it also shows you what the data is dependent on. For example, exposure is based on vapor pressure and molecular weight. For the toxicology data, we have used industry standard tools that are already available. For the scores calculations, we have our own algorithms that we have defined based on the United Nations guidelines, EPA guidelines, and REACH guidelines. And we also took into account some of the other guidelines that the industry has provided, like solvent guide and reactant guide by GlaxoSmithKline. We defined the algorithms, and then we have actually vetted them with the help of our advisors who are industry experts, like Dr. David Constable. And one thing that we also provide is, since the algorithms for these are not standardized yet, you may have your own way of defining some of these toxicity scores. And if you would prefer, we can actually accommodate those algorithms and show you the data with your own calculations. Now let's talk about how the different departments can benefit from this. As I mentioned before, some of the new features that are coming up within next few 3 or 4 months are the advanced search, where you can search based on the classification or properties. So for example, EHS department, you want to understand which chemicals are the fire hazards so that you can watch over them a little more carefully, or which chemicals have certain toxicological complications. For example, you want to understand the dermal toxicity or air toxicity, what do you call it? Because there are certain reactions involve certain things to be done that are more likely to cause dermal toxicity for the people. You can identify them, those chemicals by using our system. And if you integrate our product with your limb system, for example, you can actually pinpoint which area within your lab has fire hazards, or which area within your lab has certain health hazards. If people are allergic to certain things, or they are more susceptible to certain problems, they can identify which areas not to go to or be careful about too. In terms of the research purposes, we are adding a feature which is based on the structure. Even if we don't have the chemical in our database, we will be able to do on the spot toxicological estimations for that chemical. So when you are defining new molecules, you are evaluating whether to pursue certain molecules, you will be able to identify what are the potential toxicity problems that that molecule may have, and whether make the decision upon whether to pursue that or not. I forgot to mention one thing was the structure search. You can actually search the chemical by providing the chemical name, CAS number, or chemical formula, or you can also draw the structure. Or if you have a mole file or SDS file, you can just drop the file into this rectangle, and it will automatically draw the structure for you. And you can submit a new chemical for study, or you can compare the chemicals. That's it.